Hi, I'm Ross McGowan, and I'll be discussing SmallER. The goal of ER for digital voice assistants is to match entities mentioned within customers' utterances to canonical forms from their catalogs, such as smart home appliances, songs, or contact names. A robust ER solution allows customers to speak more naturally without requiring them to precisely phrase canonical catalog values when making requests. There has been a recent trend for voice assistants to enable spoken language understanding technology on the local device. Edge-deployed SLU allows users to interact with their voice assistant when there is no internet connectivity or when serving the request locally improves the user experience. However, this often requires the underlying SLU models to be redesigned and optimized for resource-constrained devices. SmallER addresses constraints imposed by the on-device settings such as bounded memory consumption and disk space and limited compute resources. Our model is trained to encode entities as high-dimensional vectors where the representations account for relative similarities between pairs of elements across a geometric measure. Our model architecture is capable of learning semantic and syntactic information, which we encode separately, as the benefit of each type of information for the classification task varies by domain. We follow a Siamese training method by executing identical models for both the utterance mention and the match candidates from the catalog. The model is trained with the triplet loss function, and the resulting objective minimizes the L2 distance between the matching pairs and maximizes the distance between the non-matching pairs simultaneously. After quantization-aware training, our model's runtime memory consumption is approximately 3 megabytes. SmallER employs two classes of data structures for its compression and search: compact tries and spatial partitioning trees. A trie is a tree-like data structure that implements a dictionary mapping. This mapping provides an efficient catalog representation that our spatial partitioning trees exploit for further footprint reduction. The tree structures accelerate inference by reducing the search space. They provide SmallER with an approximate nearest neighbor scheme that curtails the number of point-wise distance comparisons required to find a good entity match quickly. In using tree-based nearest neighbor search, one must balance the trade-off between reducing the search space, which means lower runtime latency, and preserving recall. So we add configurable search values to help strike an optimal balance for various use cases and catalog sizes. Relative to previously trained logistic regression ER models, SmallER's multi-domain neural model outperforms all 7 of our domain-specific baselines. We see the largest recall gains for domains with large catalogs, such as books and music service. Looking just at books, relative to full catalog search, we see that while recall reduces as catalogs get larger, the search space is reduced by over 90%. For music service, we report a search space reduction of 95%. Thanks for listening.